Getting solutions using the Polya's 4-step problem solving. A mother tells her son, "I was your age now when you were born." If the mother is now 38 years old, how old was his son 2 years ago? So what we are looking for here is how old was her son 2 years ago. So first, we should determine how old was his mother when he was born, because that is the son's current age. So let us use X to represent the son's age. And since the mother is now 38 years old, let us represent her age the time her son was born as 38 minus X. So our formula should be 38 minus X is equals to X. To simplify, 2X is equals to 38. Let's divide both by 2. So X is equals to 19. The son's age now is 19, and 2 years ago he was 17. Problem number 2. At present, the sum of parents' ages is twice the sum of children's ages. 5 years ago, the sum of the parents' ages was 4 times the sum of the children's ages. 15 years hence, the sum of the parents' ages will be equal to the sum of the children's ages. How many children are there? What we are looking for here is the total number of children. Since the specific ages of the parents and the children were not mentioned, we will be assigning various equations for each time scenario. So to do this, let us assign variables to represent the given items. Let A be the number of children in the family, B as the sum of parents' ages, and C as the sum of children's ages. At the moment, the parents' ages is twice the sum of their children's ages, so using our variables, the equation is B is equal to 2C. 5 years ago, the sum of the parents' ages was 4 times the sum of the children's ages, so B minus 10, which is 5 years ago from each parent, is equal to 4 multiplied to C minus 5A. We will now have B minus 10 is equal to 4C minus 20A. Now to simplify, we substitute the value of B to 2C from our previous equation to get 2C minus 10 is equal to 4C minus 20A. Reorganizing, we get 4C minus 2C equal to 20AE minus 10, then 2C equal to 20AE minus 10, divide both sides with 2. The simplified equation to represent the scenario 5 years ago is C equal to 10AE minus 5. In 15 years, the sum of the parents' ages will be equal to the sum of their children's ages. Following the pattern from the previous equation, we have B plus 15 years from each parent, which is 30 equal to C plus 15A. Again, we substitute B with 2C, so we get 2C plus 30 equal to C plus 15A. Simplified, we get C plus 30 equal to 15A. Now we substitute the value of C to 10AE minus 5, and we get 10AE minus 5 plus 30 equal to 15A. Simplified, we get 5A equals 25, divide both sides to 5, and we get 5 as the total number of children. Problem number 3. A man rows downstream at the rate of 5 km per hour and upstream at the rate of 2 km per hour. How far downstream should he go if he is to return in 1 hour and 45 minutes after leaving? We need to figure out how far should the man go downstream if he is to return in 1 hour and 45 minutes. The time equation is time equals distance over speed. The time given is 1 hour 45 minutes, which is equivalent to 1.75 hours. Since we need to find the distance, let us represent it with the letter D. He goes downstream at the rate of 5 km per hour and upstream at 2 km per hour. Now, our equation will be time, which is 1.75 hours equals D over 5 km per hour plus D over 2 km per hour. To simplify and eliminate the denominators, we multiply both sides with 20, which is the least common multiple of 5 and 2. Solving the equation, we get the simplified form of 35 equals 14D, divide both sides with 14, and we will get 2.5 kilometers, which is the distance needed for the man to row downstream. Problem number 4. The product of point 25 and point 20 of a number is 500. What is the number? We will be guessing the number, but we need to make sure that we meet the requirements needed in solving the problem. Let us try the number 50. The point 25 of 50 is 12.5 and point 20 is 10. Multiply them together, we get 125, so technically it is not the number we are looking for. Now let us try 100. The point 25 of 100 is 25 and point 20 is 20. Multiply them together, we get 500. So the number we are looking for is 100. On one job, two excavators excavate 20,000 cubic meters of earth. The larger excavator working 40 hours and the smaller for 35 hours. On another job, they removed 40,000 cubic meters with the larger working 70 hours and the smaller working 90 hours. How much earth can each remove in 1 hour working alone? In this problem, we need to determine the volume that each of the excavators excavate in an hour. To represent the volume each of the excavator excavates, let us assign X for the large excavator and Y for the small excavator. On the first job we can have the equation 40x plus 35y equals 20,000, and on the second job we have 70x plus 90y equals 40,000. To determine the value of X, we use the first equation. We rearrange by moving 35y on the other side, then divide both sides with 40 to simplify. We will have the value of X equals 500 minus 0.875y. Now let us substitute the value of X to our second equation and we get 70 multiplied to 500 minus 0.875y plus 90y equals 40,000. Arranging and solving the equation, we get the value of y as 173.91. Finally, we substitute the value of y to our previous equation to get the volume offered the large excavator. We now have X equals 500 minus 0.875 multiplied to 173.91 and we get the value as 347.8. Therefore, the large excavator excavates 347.8 cubic meters of earth in an hour while the smaller one excavates 173.91 cubic meters in an hour. Problem number 6, 2000 kilograms of steel containing 8% nickel is to be made by mixing a steel containing 14% nickel with another containing 6% nickel. How much of each is needed? We will determine how much steel is needed for each percentage. Let us use X to represent the one with 14% and 2000 minus X for the 6%. We will come up with an equation 0.14x plus 0.06 multiplied to 2000 minus x equals the 8% of 2000, which is 160. Simplifying and zomputing the equation, we get the value of x as 500, which supplies the value we are looking for the 14%. Upon applying substitution, 2000 minus 500 is 1500, which is the value we are looking for to supplement that of 6%.